this venue. It's magnificent, and I'm also very happy that during last 2 years, a lot of people invested a lot of effort, tremendous amount of effort into making .NET Runtime faster. Even if you look at this conference agenda, about one half of the sessions are about performance and how to make things faster, and then some other kinds of developers will come and we'll talk about dependency injection and build dependency injection containers, which on the other hand makes your applications a little bit slower. But, of course, if you want to write code which is maintainable and extensible, there is no other way. So this session will be about dependency injection. My name is Tomáš Herceg, I'm from the Czech Republic, and I'm running a company called RIGANTI, which develops an open source web framework called .vvm, which protects developers from writing tons of JavaScript code. Together with .NET Core, a lot of new libraries emerged, and several of them start with the prefix Microsoft.extensions.something. It's not only Microsoft extensions, dependency injection, there are also a lot of other NuGet packages starting with Microsoft extensions. Actually, the naming is not it's not the perfect naming, because if you trying to Google how to do something with Microsoft dependency injection container, you have to write Microsoft extensions dependency injection and your question, because otherwise you won't be able to find a lot of nice results in Google. It's similar like a popular container called Castle Windsor, because if you write Castle Windsor into Google, you will get the ticket prices and things for the if you want to visit the castle in Britain. But dependency injection, there is also a library for logging, caching, configuration, identity, and a lot more. This is a pack of libraries which are new in .NET Core, and you can also use them from good old classic .NET framework because they are compliant with .NET standard. The dependency injection package is one of these libraries, and it's a new thing in .NET, because in classic .NET framework there were no basic interfaces or infrastructure for dependency injection. You had to import some external library. Now this is part of ASP.NET Core infrastructure, and this package provides basic functions which you would expect from a dependency injection container. And if you are writing some applications which are easy, have several tables in the database, this is good solution for the problem. Also, it's very good for framework authors, because this package provides interfaces for dependency injection. We will talk about them later, but if you want to write some more complex library, you will probably need dependency injection inside. And on classic .NET framework, there was no interfaces for this, so you installed some NuGet packages, and it also included, for example, Autofag or Unity in your project. And then you used another library, and it also needed dependency injection, so you may have two dependency injection containers in the project. Now with these interfaces, which we'll see later, this is much easier also for the framework authors. Also, this provides only basic dependency injection functionality, but it's extensible. So if you are used to use Unity or Castle Windsor or any other DI container, you are able to integrate these external containers with this dependency injection package and use it in ASP.NET Core application. Before we talk about and show some demos, I would like to repeat the solid rules. How many of you are familiar with these rules? Okay, maybe more than half of the people. It's great. I have some simple example to demonstrate, so we can be really sure that everyone understands the concepts. The demo is a little extreme. It's not a real application. It's just a simple sample, so it may look weird that I'm creating a bunch of interfaces to actually run one line of code. But in real application, this is very important. So let's look at this simple application. It's ASP.NET Core MVC application with one controller. I just send some object, some customer object, and I want to store it in the database. So if you look at this method, it's not the ideal implementation, or well, it is because this project is simple, but in a real application, this is not a good solution because this method does a lot of things. And the first principle from Solid is single responsibility principle. You can see this method works with database, manages DB context creation. It also does some exception handling, and it also does logging, yeah? Because if there is an exception, I will append it to the file. There are many reasons why I need to change this class and this method, so that's kind of breaking of single responsibility principle. I can fix it. So I have another version of the controller, and this is kind of shorter because I have extracted some of the functionality elsewhere. I have a logging filter which does exception handling. Exception handling is done by ASP.NET Core infrastructure. So I have get rid of the try-catch block because it's implemented in the exception filter attribute. If there is an exception during processing of the request, I'm using a service called file logger. So I'm not doing logging in the filter because it's supposed to handle the exceptions. I'm also delegating this functionality to a file logger, and hopefully in the future, if I see that logging into file is not good for my case, I can implement another logger. Also, the work with database, I have created something like customer service, which is also not perfect at all, but at least it does only it has only one responsibility to take care of storing the customers. So that's the first principle. The other one, the second one, is open-closed. It says something like that if you design some interfaces, you should be careful because changing an interface is always painful. So design your interfaces so they are universal enough so you won't need to change them in the future. It brings a lot of compatibility issues. You upgrade some library, and if the library changes its interfaces, other libraries may be broken. Yeah. That's what Microsoft did between 1.0 and 2.0 version of several Microsoft extensions libraries. So many frameworks had to drop support for ASP.NET Core 1.0 and upgrade it to 2.0 because some interfaces, especially in the identity and authentication libraries, were changed significantly. Yeah, so design your interfaces so you won't have to change them in the future. How this can look in the real world? Let's look at this class. It's something like customer repository. It will be able to save a customer, or you will be able to use it for querying. So for example, I can create a method which will return all my customers. It's not perfect because if there's more than 1 million customers, it will probably keep your database down for a few seconds or minutes or whatever. But when the application grows, you will be adding more methods. In some time you will add get by category, next time you will need get by name. And if this is a class, it's not such a big deal. But if you create an interface, iCustomer Service, you will be adding new methods in the interface. And anyone who implements this interface will hate you and will curse at you because you shouldn't do it. So you should design your interfaces so they could be extensible. It can be, for example, this. We can create some abstraction because all these methods I was showing, it's just a query on the customers table. It returns a set of customers. So I have created an interface called iQuery, which returns customer, and I have this method in my interface. This is universal enough, so if I write any query which returns any set of customers, I can implement the iQuery object, and the repository or the service or however you want to call this will just return will accept this query that returns a list or enumerable of customers. It's still not perfect, but it's universal enough, and if I extract interface from this class, I probably won't have to change it in the future. Next of the principles is Liskov substitution principle. It takes care of the inheritance. For example, I have implemented this file logger here. So whenever there is an exception, the log exception method it's called, and I'm just appending the log message into a file. It's not very clever implementation because if there is a lot of errors in the application, probably you will get out of the free space on your disk because there is no deleting of the old messages and things like that, but for basic applications it can be enough. But I have seen many people, for example, if you want to change the storage and you want to log these things not in a file system but in the database, you shouldn't do something like this. Public class SQL logger deriving from file logger and overriding this method. You cannot override, but if it's virtual, you could. And here you just I don't call base log exception because I don't need this. And instead I would replace the functionality. This is wrong. Don't do it. I have seen a lot of classes which derives from list of string and try to disable some functionality by throwing not supported exception. This also isn't correct. If you want to do it correctly, you should have some ilog interface or a logger base abstract class, or maybe both, typically both, and because these classes are on the same level. Yeah, one way, the second way. But the SQL logger is not file logger and vice versa. So do not abuse the inheritance. The fourth principle is called interface segregation principle, and the idea behind it is to create a specific interface for any place where a service is used. If you have some service and it's used from two places, and one place calls one method, the second place calls the second method, it's a good idea to have separate interfaces for both of these things. For example, I have fine-tuned the repository. So I have the iRepository interface here, and it doesn't have anything inside because it implements iQueryable repository, which is used for reading, and iUpdatable repository, which is used for writing. Because on many places you only want to read the data, and requesting the complete implementation of your repository may be an overhead. So you can create specific interfaces for use cases. In the future, when the repository class would become too large, you will also be able to split the implementation into two separate classes, because you actually have these interfaces and the application is prepared for it. So if some component of the application grows and starts breaking the SRP, these interfaces should save your day. And the last principle is dependency inversion principle. And in the previous implementations of this method, I was calling new customer repository. If you need a service object, the dependency inversion principle says that you shouldn't create it yourself. You should delegate this to another part of the project, in this case to a dependency injection container. So I have created a constructor which requires one parameter of iRepository, and I am having this repository passed into my class. I'm not creating it myself because it's also a breaking of single responsibility principle. This class shouldn't create instances of repository. It should only do the magic, which is responding to HTTP post request. Yeah? So have your dependencies injected in the constructor. And also, this is very practical in a big projects, because when you look at the constructor of this class, you immediately know which requirements and which dependencies this class wants. So if you have a class and want to use it in other project, just look at the constructor and you will see what else will you need in the project. Yeah. If it's only hidden in the body of the method that you are writing to the file system, that you are sending emails, you have to go through all the code of this class. If this is stated in the constructor, it's much cleaner. So that's basically the solid principles. I think that many of you are familiar with them, but just a reminder, and for the people who didn't heard of them or heard of them many years back in the school. So, as I was saying, in the classic .NET framework, there was no built-in dependency injection container, but there was a lot of external libraries which could provide this functionality. Who of you has been using Unity? Castle Windsor? Autofuck? Simple Injector? Something else? Okay, more than half people was using something else. There were about 10 very popular containers, and they are pretty much doing the same or very similar things. The configuration of the containers is different, but it's nice to see that a lot of people actually used some DI container. Having the basic interfaces in the new packages is great for library and framework authors, because you don't have to rely on a specific container. You can use this interface, and this interface is called iService Provider, the second one. The iService collection is also part of this library, and it's a collection of registration rules of how each component should be created. It's something like a dictionary of factory methods for the individual components. The iService Provider has one method called getService, and you specify the type and you will get the instance. And that's what library authors need, because they can use any container or allow you to supply your own one. And the iService collection is also nice because every framework or library which you use can use the same API to register their own internal dependencies. We will see it in the demo in a minute. And the responsibilities for dependency injection container, and for this package, real containers do much more things than this, but there are three main responsibilities. First is creating instances of all services you need. The second one is to manage the lifetime of these instances. Because in this Microsoft Dependency Injection package, there are three different lifetimes. The first is singleton, which means one instance, rule them all, and you know how it continues. Next one is transient, which means every time somebody needs this service, he will get a new instance. And there is also a scope. What is the scope? It can be anything, and in ASP.NET Core, typically, it is an HTTP request. But you can implement your own scopes. For example, if you were writing some background processing or queue processing, something like that, so you can, for every item in the queue, you can create your own scope and have your own instances of the services. Yeah, and then you finish processing the item, so you will dispose the scope, all the services gets disposed, and when you start processing another item from the queue, you will create a new scope. That's the same principle as with the HTTP requests. Every HTTP request has its scope, and internally they are using the async local class for managing the scope. So basically, if you are using async await, you will still be in the scope which belongs to the particular HTTP request. And the third responsibility is to dispose instances that are no longer used. When the scope ends, the container will call dispose on the components automatically, provided that they implement the iDisposable interface. So when the HTTP request ends, all the scope services are disposed for you automatically. So how does it look in ASP.NET Core? I need to switch into another Visual Studio. Okay. So the ASP.NET Core application has this entry point. It's a web application, but it has the program and main method where the pipeline is configured, pipeline for Kestrel, and the startup class is called. And the startup has two methods. One is configure services, and as you can see, there is the iService collection parameter. And this is a collection of services, and every library, every framework implements its extension method, which will register everything the framework needs in this collection. So you can see there is services at MVC, which just registers all the MVC services into the collection. There is some logging middleware, so you will see add logging, and all of these are extension methods. In this demo, I have created 3 services. They are very dull. They are not doing anything important. They just generate a new GUID. And I'm registering the services, so add singleton, add transient, add scoped. You have to specify the lifetime for these classes. You can register a class, or you can register an interface. Typically, you will be registering interfaces, which means that you will need to add a second parameter. I could say iService1 is implemented by this class, but I don't have this interface declared, so that's a compile error. In the constructor, you need to request the service, the interface, yeah, the iService1, and the implementation container will give you implementation, the instance of this class. And of course it's recursive, so if the service1 class has some parameters in the constructor, the container will recursively resolve the entire dependency tree. Yeah, but you need to use this type in the interfaces. Okay, so in the constructors, sorry. So that's the registration of the services, and the configure is used to build the request pipeline. So I'm saying use MVC, and this method assumes that you have registered all the MVC services into the service provider, which is created automatically for you in this case. But it's somewhere in the background. And when I look in the controller, I have a silly method here. This controller requests 5 parameters. Yeah, service 1, it's a singleton, so there's only 1. The second one, service 2, is transient, and I'm requesting 2, and you will see that these are different instances because it's transient. Every time somebody needs this instance, he will get a new one. So service 2 and service 2 alpha and beta will be different instances. Service 3 and is scoped, so if you are in the same HTTP request, you will always get the same instance. So, and all these services just create a new GUID. Yeah, so nothing special here. I am in the constructor. I am just generating a new GUID. All the services are the same. And when I run this application and call the GET request, it will just print out all the GUIDs. So when I run this, you will see some GUIDs. I will make this bigger. So you can, when I refresh the page, you will see that the first one is still the same because it's singleton. The service 2 alpha and beta are different because it's transient. So every time I request, I get a new instance. You can see that they're always different. And when I refresh, the last 2 are always the same, but when I refresh, they will change. So there, it's one instance per HTTP request or per scope. Yeah. So that's a demonstration how the lifetimes work. And I'm not. If I run this with debugger, you would also see how these services are disposed. But I forgot to run debugger. But when the container calls dispose, these services are disposed. The singleton is not disposed. It's never disposed because it still lives until the application ends. But the scoped services are getting disposed when the scope ends, which means when the HTTP request is processed. So that's the basics of the dependency injection. And if your application is simple, this is the way how you can do it. It's a good idea to create an extension method for the service collection. So don't register all the things here, because even if the application is simple enough, you will have tens, maybe 1,000, maybe 20, 30 rules here. So this method would be long. So create your extension methods and create some groups of registration for the classes and services which belongs to each other. If you are building something bigger, you may appreciate features provided by real containers. For example, if your class needs to create instances, but not now, but later, you can inject factories. So in the constructor, I won't request DB context, I would request func of DB context and create the instance whenever and how many times I really want. Or you can, for example, have injected the lazy objects. Some objects are it takes time to initialize some objects, so you may do it later, not on the application startup, but later. So you have to inject the lazy of something, and the container will provide an implementation for this automatically. You just register a rule for T, and container will generate the lazy T for you automatically. Also, in larger applications, you can use many naming conventions. For example, find all classes which name ends with query or which implement some interface and register them all at once. Of course, you can do it even with the Microsoft Dependency Injection package, but you have to use reflection, and you have to browse the assembly types and verify if the type really implements this interface. Many containers have nicer and simpler syntax for this, so there is some Fluent API which will be able to discover all these classes quickly. Also, many containers support open generics. It means that if I want to register eQuery of anything and use some service, for example, entity framework query of anything. Yeah, so it's called open generics, that the generic type is basically a variable. Also, external containers support things like custom lifetime policies. For example, you can use pooling. Here's 5 instances, and you can use them, but not create additional ones. Or, for example, you can have per-thread strategies where it depends on which thread the code is running. So every thread will have the same its own instance. And also the containers, for example, can do interception. Who has been using interception? Few people, okay. Interception is basically automatic generation of proxy classes. If you have an interface, and for example, if you want to do exception handling on every method in the interface, the container can generate a proxy class which implements this interface and which you can use, and it will do the exception handling, and in the try statement it will just call the real service. So you can have existing service, apply this automatically generated proxy class which will do the exception handling, and it still implements the interface, so you can use it anywhere in the application. It can be used for logging, tracing, exception handling, and permission checking, and many other features. Maybe some of you has seen a product called PostSharp. It's a similar thing like interception, but it's much more advanced because it happens in the compile time. Yeah? The compiler spits out the assembly, and PostSharp takes it and can do also interception or any other code rewriting. Interception in the containers happens in runtime, and when the container is configured, it will generate the proxy class and use it. Okay, so how to involve some external container with Microsoft Dependency Injection. I will be showing how to do Autofuck and Castle Windsor, but pretty much every container can be integrated with this. So let's look at another demo. No, it's Windsor one. So this one. Okay. So I have changed the configure services method, so it returns iService provider. If you create a new project, this will be just void. But if you change this to return iService provider, ASP.NET Core will use this iService provider which you have created. If this is void, ASP.NET Core would create its own service provider based on the service collection. So I'm still using the service collection because all the libraries and frameworks need this interface. So I'm registering MVC and logging, and then I'm using Container Builder, which is a class from the Autofuck package. and I'm registering a module. A module is basically a group of registrations. So when I enter this class, you can see that I'm also registering service 1, 2, 3, but using autofuck terminology. So singleton is single instance, transient is instance per dependency, and scoped is instance per lifetime scope. Every container has its own words for the same things. And then I also say builder.populate services, which takes the iService collection, reads all the rules, and registers them in the autofuck container. And finally, I will build the container and return autofuck service provider, which is an implementation of iService provider interface done by the autofuck container. So basically, that's how I integrate my own container with this built-in infrastructure. I take whatever is in the service collection, combine it with the configuration of the container, and return the iService provider. The libraries have APIs for this. If you look at the NuGet packages which you need to have in your project, you will see that this is autofuck, and also autofuck extensions dependency injection, which is the bridge between autofuck and the iService collection and iService provider interfaces. Yeah, it's in a separate package, so you need two of the packages. Very similar situation is in Castle Windsor. Oh, sorry, not the correct one. This is the correct one. Also, I will create Windsor container. I will install my services, which is done in autofuck, it's module. In Windsor, it's installer, but it's also just a class which holds several registration rules. So I'm registering service 1 as singleton, service 2 as transient, service 3 as scoped, and you have to specify which scope accessor you want to use. In this case is MS scoped accessor, which is bound to the ASP.NET Core way of handling the scopes, but you can create your own scopes and implement your own scope accessors. And also there is a class Windsor registration helper, which combines the container registrations and the iService collection, and also returns the iService provider. And when you return the iService provider, the ASP.NET Core libraries and everything which is in ASP.NET Core will use this iService provider. When I'm in the controller, in the controller, there is in every action there is the HTTP context object, and you can see request services, which is the iService provider. So if you want any service, you should ask for it in constructor, but sometimes you can also use this, typically when the type is dynamic and you don't know in the constructor at the compile time the type is unknown. So you can also request services by using this called get service or get required service or things like that. So this is the way how to request services from the HTTP context. And also, if you are building your own frameworks or libraries or things like that, you can you may want to create your own scopes. For example, as I was talking about the queue processing, you may want to have a separate scope for each queue item. So you need to get the service provider, and in the service provider there is a special interface already registered. It's called iService Scope Factory, and it has the create scope method, and this object, the scope variable, which is on the beginning of the using block, it will return its own service provider, which is valid for the scope. So you can use the new service provider for the scope. And when you dispose it, all the services in the scope are disposed as well. So if you are building a framework or a library or anything which requires custom scopes, just request the iService scope factory and call create scope, and you will get a new service provider with your scope services. So that's how you can integrate with this infrastructure. We have also seen the Windsor. So best practices for using dependency injection. Do not register everything in configure services in the startup. Make groups of registrations that are related to each other, and use modules or installers or whatever the specific container, whatever name the container use. Also try using naming conventions. Get all classes in this namespace. Get all classes with name ending by repository. Get all classes which implement this interface. It's very useful to have such conventions in the application, and you should document them, so new people who are added to the project, they will be able to get familiar with the conventions quickly. And also be careful when you are working with the lifetimes, because singleton instances needs to be thread safe. They shouldn't have their own state, and if they have, you need to make it thread safe. And singletons should not request services which are bound to a specific scope, because the scope doesn't have to be available at that moment. If you have a logger and it needs any service which is scoped, logger typically is singleton. So if singleton needs something scoped, there is a problem. So avoid this, because it will crash with some exceptions. When the scope ends, the service would be disposed, and that also it may cause memory leaks. So be careful about these scopes. Okay, and that's it. So if you have any questions, I'll be happy to answer.
What benefits have built-in DI container comparing with another DI containers? So when should I use a built-in container, and when should I use another containers? Thank you.
Okay, so I will repeat the question. The question was when it's beneficial to use external container in comparison to use just the default one. For simple applications, for some demos, I would use the default built-in one. And for something larger, when I need naming conventions, when I need auto-generated factories, maybe interception, these features that are not available in the built-in container, I will use Castle Windsor, but mostly because I'm used to use it. It's also what libraries you like, what libraries are you used to, and because there are these basic interfaces, you can easily change the container because it's only a few classes in your application, it's some modules or installers, and if you find out that this container is too much overhead for your application, if it's too much, if you don't need it, or if you just get tired of Unity and want to switch to some other container, it's very easy to change. It's only the syntax of the registration, and you can also choose if you are used to use some container, just use it because you can. It's not such a big deal because you can swap the containers quite easily. Much easier than, for example, swapping the database from MySQL to Microsoft SQL. Okay?
Thanks for the presentation. And talking about best practices, could you give me advice for using service locator pattern in scope of dependency injection? Because I know it's now it looks like mostly is like an anti-pattern, but it can be very useful for different things.
Okay, so there is a question about service locator pattern, which is when you call get service manually, it's called service locator pattern. I think that service locator pattern is not a problem when you are doing at the start of the application, because you have to request some services when your application starts. Sometimes it's hidden in the framework that ASP.NET Core will do this for you, but if you are writing some console applications, you will configure the container and then call get service, but do it only when the application starts, or if there is no other way to do it, if you are building some components, some infrastructure code, and also if you are doing tests. In tests, you will often need to use the service locator pattern. I wouldn't say it's an anti-pattern, because every pattern can be misused, and it's just about this pattern is good for these things. Use it on these things, and not on something else. So I wouldn't say service locator is not correct or it's anti-pattern. It's not. It has some specific scenarios where it can be used, but if you are using it in your application code, if you have some customer repository, for example, which saves the customers, and now you see, okay, customer wants to be notified by email when his information is changed, so I will call request services, get service, my mailer, send message. This is wrong, because you are hiding your dependencies, and if you look at the class constructor, you won't see that this class sends emails, and if you are, for example, testing this class, you may send the email to a real customer which you don't want. So use service locator wisely. It's not a bad pattern, but it's good for tests or in the application startup.
Thank you for your presentation. And
You're welcome.
I'd like to ask you just one question about terms which I have seen here. You have mentioned solid, and the fifth principle is dependency inversion. And during this presentation, I heard dependency injection. For me, there are two different terms. And firstly, I'd like to ask you, what is the difference between these terms, dependency injection and dependency inversion, and what about inversion of control?
Okay. So these terms are similar, they sound similar. Dependency inversion. Dependency inversion is just the principle that you are getting these services in the constructor. Injection is the way how these objects are given to you. It's maybe the dependency inversion is the principle, and dependency injection is the implementation of this principle. Yeah, it's the way how the containers really do the thing. Yeah, the principle is dependency inversion, and it's only that you should not create the instances yourself, have them supplied from somewhere else. And the specific way how these things are supplied is the dependency injection. Does it answer your question? Okay.
Okay, so unfortunately we're out of time, so that was the last question. So now we need to select the best one. Best question.
Okay, best question. Oh.
Do you need my help?
I don't know which question was the best. Maybe the first one.
Okay.
Okay.
Great. Thank you, Tomáš.
Thank you. If you have any other questions, I will be here for the rest of the day, so catch me and we can talk.